Hey guys, Trey back again with another video. And in today's video, we're going to do something completely different than what we normally do. I've been playing around with Rust a lot lately. I found out that you can create a Rust library and use that library in C. So you can write your code in Rust to create a library, and then you can take that library and compile it with your C code and run the functions from the Rust code. So we're going to do that today. It's actually pretty straightforward. Let's go ahead and get started. So the first thing you're going to need is to install Rust. I'm not going to show you how to do that here. I'm going to have a bunch of links in the description, which will help you install Rust, install GCC, and pretty much anything that you're going to need to do what we're doing here. So if you see me running a command and you don't have that program, just go ahead and install it through one of those links. So yeah, let's get started. The first thing I want to do is, well, set up a Git repository for this. So what I'm going to do is I'm going to say git init. All right, so now this Rust and C folder is a Git folder, and then I want to create a Rust project. Now you create Rust projects through, I guess it's kind of like a package manager. It's called Cargo. So we're going to create a library crate, which is what it's called. So we're going to type in cargo new, and I'm going to call this simple math. So we're going to create a math library here, and then I'm going to do dash dash lib to tell them that I want to make a library crate. So as you can see, we created the library simple math package. All right, and it has popped up here. So if we go up here and look, this is what the basic layout looks like. We're going to go in this cargo.toml file, and this is basically how you configure your build basically. So in here we want to tell Cargo that when we run a build that we want to compile this to a C library pretty much. So what we're going to do is we're going to add another section here. We're going to call it lib, and then we're going to give it a name, and this name is going to be lib simple math. All right, so that's the name of our library that we're going to create. And then we also need to pass in a crate type. So a crate, just think of that as like a package. So we're going to want to create a C dynamic library. Okay, so we're going to type cdylib, and this is going to tell Rust to compile this to a C dynamic library. But all right, so that's pretty much it for this cargo.toml. You can close that out, and then we're going to go into our source directory in our librs, which is automatically created for us. So we're going to go here, we're going to erase everything out of here, and then we want to go ahead and create our library functions. So we're just doing a simple math library, which is just going to have add, subtract, multiply, and divide. So I'm going to create these functions now just using regular Rust, and then we'll add in some stuff for the compiler after we write out our function. So if you're not familiar with Rust, go ahead, take a look at the Rust Lang book. They have pretty much anything you need to know about Rust in there, so you can learn how to write out the functions and stuff. I'm going to assume that you know how to write out functions in Rust, so I'm going to do a public function. We're going to call it add, and then we're going to have a value of 1, and it's going to be an I32, which is just a 32-bit signed integer. And then we're going to do the same thing for the next value. It's going to be value 2, I32, and we're going to return an I32, which is basically just going to be the added together numbers. Now, the reason why we used an I32 here instead of some other type is because we want this type to match the type that's going to be used in our C language. So we're just going to be adding two integer values. And in C, an integer is an unsigned 32-bit integer. All right, so that's what we're using. That's why we're using this here. Okay, and then we're just going to return the values added together. So it'll be value 1 plus value 2. And that's it for our function. All right, so in Rust, this is it. This is a function. But in order to compile this for our C code, we need to tell the compiler to do some special things with this function. All right, so the first thing we're going to need to do is basically tell the compiler, hey, this function is going to be used externally in a C program. So the way we do this is in between our pub and our fn, we're going to type in extern, and then we'll do C. So put it in quotes. So this is going to tell the compiler, hey, this is going to be an external C function. All right. And then there's one other thing we need to do. So when the Rust compiler compiles some code, when it compiles these functions, it changes the names of these functions. So when we want to add this library into our C code, we can't have the name be changed because we need to have a set name. So we need to know what the name is. And in order to tell the Rust compiler when it compiles not to change the name, we need to add some special syntax up here at the top. So we're going to say hash. Then we're going to do square brackets, and then we're going to type in no underscore mangle. All right, so basically what this is doing is telling the C compiler, hey, don't change this name when we compile. And then what this is doing is basically telling it, hey, we're going to use this as an external C function. Okay, so that'll help the compiler out. So now this function is completely done. We don't need to do anything else to it in order to compile it and use it in our C code. So what we're going to do is we're going to copy this, and we're going to paste it for basically the other three functions, the subtract, multiply, divide. So I'm going to do this 3 times, and then I'm going to change these names. So we'll have subtract, then we'll have multiply, and then we'll have divide. All right, and then let's change the actual actions that we are returning. So there we go. We're doing subtract here, doing multiply here, and we're doing divide here. Now I'm not going to actually do a check or anything to make sure this is not 0 and all that stuff. We don't care about that. This isn't going to be an actual library. This is just showing you how you can use Rust code as a C library. Okay, so we're going to do that. It's very simple, very done. So pretty much that's it. That's all we have to do for the Rust side of things. So I'm going to exit out of this librs, and we're going to go ahead and build this Rust code into our library. So the way we do this is we're going to go to our terminal and make sure that we're in our root folder. So I'm going to say cd simple math, which is this folder here. And now that we're in our root folder, we want to go ahead and run the build command. So before I do that, we already have something here in this target folder. I'm just going to remove this by typing cargo clean. As you can see, it removed our target folder. And then I'm going to rebuild this. So I'm going to type in cargo build. And that will build us a new target directory. And if we go into target debug, we'll see this lib simplemath.dll, and this is the file that we want. Okay, so that's the one. So what I'm going to do is I'm going to copy that out into our main directory here, the simple math directory. So what I'm going to do is say cp, there's going to be target debug, and then we want the lib simplemath.dll, and then we're going to copy it out to the dot, which is basically this directory, which is simple math. So as you can see, it came out here. We're good to go. Also, yeah, before I even go further, this DLL file is because I'm running this on Windows. If you run this on Linux, you're going to get a .so file. That's the file you want. You want the .so, which is basically a shared object file. So forgot to say that if you're on Linux, you will see a .so file. Make sure you copy that file out. So to continue on, we need to go ahead and get everything set up for our C side of things. So the first thing we want to do is create a header file that has these functions in it. So that basically that declares these functions. All right. So what I'm going to do is I'm going to create a new folder. We're going to call it include. So I'm going to say mkdir include. All right, so now we have this include directory, and then inside of this directory, we're going to want to create a header file. So I'm going to say touch, and then inside of this include folder, we're going to say simple math.h. So that'll be our header file. So you can go through the UI and create it that way. I'm just using the terminal because I like it better. So when you're copying out this file and stuff, you can do that. All right. So now we have this simple math.h. So what we're going to do here is we're going to create the signature for the functions that are in our library. So what I'm going to do is I'm going to open up our simple math, and I'm going to pull this librs off to the side so I can see. I'm I'm going to close this stuff down so it's easier to see for you guys. And then here, I want to create our functions here. So what I'm going to do is I'm going to say int add, and then we'll have and then we'll have int val1, and then int val2. All right. So that basically is what we're going to use to call this function. So as you can see, we take a value, an integer in, and then we return an integer. So here's our return, here's our integer in, here's our integer, other integer in, and that's it. So now we're going to copy this, and we're going to do this for the other three functions. All right. So we have add, we have sub, we have multiply, and divide. Okay, so there's one other thing I want to do that's going to basically make sure that we don't add these functions in multiple times once we do our compile. So not really going to explain it too well. If you want to look it up, just go ahead and do your Googles. But I'm going to type it in up here. Just follow along if this is what you want to do. We're going to say if endif, which is basically saying if this is not defined, which will be simple math h, then we're going to define it. So we'll say define simple math h, and then at the bottom down here we're going to do another hash, and we're going to say if. All right, so basically what this is doing is when the code's compiling, it's going to say, hey, do we have a simple h defined already? If we don't, we're going to define simple h, and we're going to add in these functions. But if we already have defined this before in our program, then we won't run this. All right. So that's pretty much what this is doing. It's not really important to what we're doing today. So if you don't understand it, don't worry about it. Doesn't matter. All right. So now that's pretty much it. We are done with that. Now we just need to create our actual main C program that's going to actually call these functions. So the way we'll do this is we're going to create a file. I'm going to call it main.c. So now we have this main.c file. I'm going to open that up, and then I'm going to import some of the header files that we need. So really there's only going to be two. There's going to be one so that we can print out the result, and then the other one is going to be our actual simple math.h. So I'm going to say hash include, and then we're going to do angle brackets, and then we're going to say stdio.h, and that's going to allow us to use the printf function to be able to print out to the screen. And then our next one will be include. We're going to use quotes here, double quotes, and then we're going to pass in our simple math.h file. So that's the file that we just created. Okay. And now we need to go ahead and create our main function. So we're going to do int main, we'll say void, and then we'll just return 0. All right, so that will set up the skeleton for our main. The next thing we need to do is actually call our add, subtract, the math functions from our simple math.h. So what we'll do is we're going to set up two integers. So I'm going to say int val1 is going to be equal to 10, then int val2 will be equal to 5, and then we'll call our functions and print them out. So we're going to say printf, then inside of here we're going to do %d plus %d equals %d. All right, and then we're going to add a new line, and then let's add in our values. So the first %d is going to be our value 1, second %d is going to be our value 2, and then we're going to call add, and then pass in val1 and val2. All right, so that'll be our third %d. All right, so this %d gets replaced by that, and then the add by that one. So it should say 10 plus 5 equals 15. That's what we should get here. All right, and then we're going to do this same thing for the other three functions. So we'll just copy and paste that. Then we're going to say sub, and then multiply, and then divide. All right, and then let's change these as well so we don't. All right, and now this is it. We're done writing code. Now we just have to compile our C code and then run it. So In order to compile our C code, we're going to have to use GCC. So if you're on Linux, I think GCC comes installed by default unless you're on Arch. I will post a link to a video in the description where I show you how to install GCC on Arch. If you're on Arch, Windows, you have to install. There's a couple of ways I think you can install it, but I'll post links in the description to how to install all this stuff. All right. So once you get GCC installed, you're gonna type in the command. You got to make sure you're inside of the root directory here in Simple Math root directory. Then we're gonna type in GCC, and then we're going to type in -o. This is going to be our output file. I'm just going to call it main, and then we need to put in the file that we want to compile, which is our main.c. And then we need to tell the compiler where this simple math.h file is. So it's in our include folder. So we want to tell it that, hey, look in our include folder to find this simple math.h. So the way we do that is we type in dash and then capital I, and then we're going to type in include, which will point that to our include directory. Okay, and then also because if we look at our simple.math file, it's just definitions. It doesn't actually have any implementations of this code. So we need to tell the compiler where to find the actual implementations of this code, and that is here in our libsimplemath.dll. All right. So in order for us to do that, we need to tell the compiler first what is the name of the library that we're looking for, and then second, we need to tell it where is that located. All right. So the first thing we're going to tell it is we're going to do dash lowercase l, and then we need to put the name. So it's going to be simple math. That's the name of our library. And then we need to tell it where is that library, and it's right here next to it. So we're going to say dash capital L, and then we'll just put a dot. Okay. So this is going to tell the compiler where that file is located. Once we do that, we can hit enter, and now we see that we have a main.exe file, and that is our executable file. So we can execute this file by typing in /main.exe, and as we see, our code actually ran. So now we can see that our addition worked. 10 plus 5 is 15. Subtraction worked. 10 minus 5 is 5. Multiplication worked. 10 times 5 is 50. And division works. 10 divided by 5 equals 2. So we see that we compiled our library using Rust, and then we ran those functions using C. All right. So that's pretty much it for this one. Just thought that was cool, and seeing how you can kind of interchange those. Yeah, that's pretty much it for this one. Thanks for watching. Like and subscribe to the channel and all that jazz, and I will see you guys in the next video.